Welcome to Digital Toolbox. Today we'll go over how to apply Grasshopper to Rhino points by using the tree definition created in the Evaluate and Random tutorial. We'll also go over how to deal with data matching and how to rotate objects or curves. So to get started, I'm going to create points in Rhino, and this will tell me where the trees will be placed. Next, I'm going to go back to Grasshopper and then go to Parameters, go to Geometry, and go to Point. And now we can apply Grasshopper to the Rhino objects. So we're going to right click on point and we're going to set multiple points. I'm going to set the points here one by one, or we can just manually click them, all of them at once. The order of the points that you click do matter if you're creating a curve through them or a line. Since we're just placing trees, it won't matter. Then right click when you're done. Next, we'll apply our circles or our tree to the point. So we're going to connect the points to the P. And now you can see that each point has a tree, but only one branch. And this has to do with data matching. So I have a preset definition that I'll explain what data matching is. So I have two lists of points. The bottom has 5 points and the top has 11 points. I'm going to create lines through them. So if I double click on the work plane and I type in line, it'll give me all the line buttons. So I'm going to click on this one, and then I'm going to connect these 2 points together. So if you right click on line, the line button, by default the longest list is selected. What the longest list is that if you have 2 lists of numbers or points or items, and the shorter list will connect to the longer list, and the last item in the shorter list will connect to the remainder of the items that weren't connected in the longer list. So that's confusing to just listen to. So this is the example of the longest list, and you'll see if I clicked on the shortest list that now that only the bottom 5 points connect to the top 5 points. And then if we click cross-reference, it gives you all the combinations of lines that can be connected through these 16 points. So if we go back into the tree definition, to get all the possible branches that we have selected by choosing the number of branches in the random generator, we have to go to the evaluation button and pick cross-reference on both buttons. So now that each tree has 10 branches, so the next thing we want to do is to rotate these trees so it looks different. So each tree looks different. So to do that, we're going to go to X form, Euclidean, and then pick rotate. We need 2 of these because we have 2 sets of circles. And then we're going to put G, which is geometry, into the circle since that's what we want to rotate. And then A is the angle in radians. P is the reference point per circle. So that's the points that we've created in Rhino. And then the angle, since I want them random, I'm going to copy and paste this random button, random generator button. And then for the range, we want it from 0 to 2 pi, which is 360 degrees. So we're going to go to scalar and grab an interval. And then for A, I'm going to put in 0. So I'm just going to grab a number in parameters and primitive. I'm going to set this number to 0. I'm going to put it into A. I'm going to go back to scalar. I'm going to go to constant, and then I'm going to grab the pi constant. So if you right click on N, you can set the number as in 2. So it becomes 2 pi. 2 pi is 360 degrees. So now if you hover over R, it goes if you hover over R on the left side, it goes from 0 to 2 pi. And then N, we want the number of points. So to count the number of points, we're going to go to logic, go to list, and here it says list the length. So we're going to count the number of items in the point list, and then we're going to connect this to N, which is the number of values that we want, which is 7 since we have 7 trees. And then I'm just going to copy this slider so I can control the type of the random generators angles. and then apply this to the angles in the rotation button. Then we'll apply the rotation to the evaluative curves, so that now the curves can be rotated. I'm going to turn this off by unpreviewing it. So now our trees have different rotations on each tree, and it's dependent on the points. So we can also move the tree if we don't like where it is, and it will still be applied to Grasshopper. So that's how you create multiple trees from points, and thanks for watching.